Today we're going to look at another way to be able to solve quadratic equations besides graphing and factoring. We're going to look at completing the square. Now we're first of all going to start off with some problems that will lead us up to completing the square. But let's consider this here. Suppose we wanted to solve this. There's a couple ways we could do it. We could set it equal to 0 and solve it. But there's another way. We could just try to get the squared term by itself by getting rid of the 16. So let's go ahead and divide both sides by 16. Then 16s on the left would drop, and we'd have 49 over 16 on the right. Then to finish getting x all by itself, you got to get rid of the squaring, so you'd have to take the square root of the left side, which undoes that, leaving you with just x. And since you take the square root of the left side, you'd also have to take the square root of the right side. Remember, when you take the square root, you need to have plus or minus, because a negative 2 squared or a positive 2 squared both give you the same answer of 4. So when you do the reverse process, you got to remember to have both possibilities occurring. So we're going to have plus or minus the square root of our 49 over 16. When you're dealing with roots again, you can take the square root of the top or the square root of the bottom. Square root of the top is 7, square root of the bottom is 4. So in this case, our two answers are 7/4 or negative 7/4. Well, we can do the same thing here, because in the last problem, we had something times something squared. Same idea here. We have something times something squared. The only difference is here on this, what's being squared is something more. But we can still go ahead and try to get the squared term by itself like we did in the last one. So you can go ahead and try to get rid of the 9 by dividing both sides by 9. So then the 9's drop out on the left. Now you got to think, well, what do we have to do to get rid of the squaring? Just like in the last problem, we can do the same thing of taking the square root. Taking the square root of the left side undoes your squaring, so the square drops, and then take the square root of the right side. Remember your plus or minus. So on the left side, nothing changes. Now, since it's the square root of a fraction, you can take the square root of the top over the square root of the bottom. You then need to go ahead and finish getting x totally by itself, so that means you got to go ahead and add 1 to get rid of the subtract 1. So add 1 to both sides, and we get this. So we really have two answers, 1 plus the square root of 7 divided by 3, and a 1 minus the square root of 7 over 3. But the shorter way to write it is like this here. Now, if this right here ended up this being a normal number, so suppose you had 1 plus and minus 2/3, well, yes, I would then break it apart and simplify each one. And here we would get 5/3, because remember 1 is 3 over 3. And then I would also do the other one of a 1 minus 2 over 3, and we get 1/3. But since we have a root here in the second part, there's really no way to simplify each one, so we're going to leave it just as this. But if it was just a normal number being added or subtracted like our 2/3, then we could work it out farther yet. So let's go ahead and take a look at this one here. This is referring to what's called the square root property. And your book will have questions that say solve using the square root property. Basically, the left side of your equation ends up factoring into two identical parentheses. When you factor the left side here, it factors into an x plus 7 and an x plus 7. Using your square root property, when they're telling you to do that, the left side should always factor into two identical parentheses. Well, an x plus 7 times an x plus 7, you could write as an x plus 7 all squared. Well, now it's just like what we were looking at before. To get rid of your squared, you take your square root. Square root of the right side would be plus or minus. Square root of your 64, you know, is 8. Then you got to go ahead and get rid of the 7, so you'd have to subtract a 7 from both sides. Now, since it's a normal number being added or subtracted after the plus or minus, we're going to break it apart into two options. The negative 7 plus 8 and the negative 7 minus the 8. And we're going to work out each one of these. So here we would get 1. Over here we would get a negative 15. And these would be our two answers. However, if it was, say, negative 7 plus or minus the square root of 8, there wouldn't be any way to simplify and combine the two terms together. So we would have left it. But since it was a normal number, we break it apart and work out the two answers. So we can do the same thing here. The left side is going to factor into two identical parentheses of an x minus 2 and an x minus 2, which you could write as an x minus 2 all squared equaling 8. Then you'd want to go ahead and get rid of your squaring by taking your square root. Now we have this, but looking at the right side, you should say, oh, square root of 8. Ah, that simplifies. Because you know when you're dealing with the square root that 8's not a perfect square, but 8 does have a factor, something that multiplies into it, that is a perfect square, because 8's really a 4 times a 2, so you could simplify it. So the square root of that 4, you know, comes out front as a 2, because the square root of 4 is 2. This 2 here you can't do anything with, so it's still hanging out inside the 2, or the root, I mean. So now you got to get x by itself by adding 2 to both sides. So then we end up getting our 2 from this, plus or minus this here. We cannot combine these together because this first 2 has no root, so they're not like terms. So now we want to look at the steps of completing the square. Basically, you want to get the number in front of the squared term to be 1. Get the variables on one side by themselves by taking the constant to the other side. Add half of b squared to both sides. Remember, b is always the term in front of the variable to the first power. Factor, and then take your square root. And what we've been doing on the last several problems, for the most part, comes into play with the last several steps. So let's go ahead and complete the square with this one here. It says get the coefficient in front of the squared term to be 1. We have a 3, so we got to get rid of that 3, so let's divide everything by 3. All three terms on the left and the term on the right. So over here we have a 1x squared, a 2/3 x, and a minus 1/3 here. Second step says get the variables on one side. So we got to get these by themselves. We got to get rid of this minus 1/3. So in other words, you have to add 1/3 to both sides. Next step says add half of b squared to both sides. Remember, b is always the term in front of your x to the first power. So we're still going to have that. It says half of b squared. So we got to take half of this. Half of 2/3. Half of 2/3, 1/2 times 2/3. Well, remember in multiplying fractions, 1 over 2 times 2 over 3. There's two ways to do it. You could just multiply the top, multiply the bottom, get 2 over 6, and then simplify, and that's where this 1/3 comes from. So that's the inside here, it's just 1/3. But it says you also need to square it. So we'll have to square that. So we're going to have a plus of 1/3 all squared here. And then we'll have to have that on the other side, because if we add something on the left side, you got to add it on the right side, a 1/3 squared over here. Now, the left side, just like that square root property stuff, should factor into two identical parentheses. So if it factors into two identical parentheses, you should be able to write it just as one parenthesis all squared. And that's what we're going to do here. Question is, what does it factor into? Well, you can ask yourself, what's being squared in the beginning? That's an x, so I'm going to put an x there. The sign that goes after the x is always the sign that's after your squared term here. Now, what goes at the end? Well, you got to look at the end up here. What was being squared up here? It was your 1/3. So I got to put the 1/3 there. Now, the right side over here, I'm going to just go ahead and work this out to try to simplify it down. Square the top, square the bottom, that's where the 1/9 comes from. Left side over here doesn't change. The right side then combines into 4/9. Because remember, to add fractions, you'd have to have a common denominator. 1/3 would be 3 over 9 plus your 1 over 9. That's where the 4 over 9 comes from. So on the left side, we have this. We're trying to solve it for x, so you got to get rid of the squaring. So take your square root of the left side, so then you'd also have to take the square root of the right side. Square root of the 4 is your 2, the square root of the 9 is your 3. So then you get x by itself. So you'd have to add 1/3 to both sides, plus or minus your 2/3. Now since there's no root here, it's a nice normal number, we're going to break it apart into the two different ones, the 1/3 plus 2/3, and the 1/3 minus 2/3, and we'll get our two different answers of a 1 and a negative 1/3. So we'll go ahead and do that on this one here. Step 1, get the coefficient from your squared term to be 1, so we've got to get rid of your timesing by 2, so we'll divide everything by 2. And we're left with this. Then you got to get your variables here by themselves, so you got to get rid of your 15/3. So we need to go ahead and take that to the other side. By the way, I spotted a typo. There was a negative sign here, subtraction sign. I just changed it to a plus. So make sure you had that copied down correctly. So we get our variables here by themselves by subtracting this to the other side. So then you got to do that half a b squared thing. Your b is this right here. So you go this times 1/2. So you multiply the tops, multiply the bottoms. So this is b. That's what we need to add to both sides and square it. So we got to take that 11/4 that we just came up with and square it. That's what we got to put on the left side. Plus we got to do the same thing to the right side. Because what you do to one side, you got to do to the other side. The left side then should factor into two identical parentheses. So you could write it as one parenthesis all squared. Remember, what goes in the beginning, you ask yourself, in the beginning here, what's being squared? That's an x. The sign is the first sign you have up here. What goes in the end of our parentheses right here is always looking at the end, what was being squared? An 11/4. Now the right side will just go ahead and work out. You have a 15/2, you square the top, square the bottom, that's where the 121/16 comes from. So we have this on the left. The right side, when you add these together, is 1/16. Because you'd have to have a common denominator, or you could use your calculator. So to finish this, we got to get rid of our squareds. We'd have to take our square root of the left side, square root of the right side. Square root of your 1/16, square root of your 1 is your 1, square root of your 16 is your 4. Finish getting x by itself, so we'd want to go ahead and subtract an 11/4 from both sides. But now, once again, since this is a normal number, you'd break it apart into the two separate ones and get your two separate answers. However, if this was a square root here, you'd have to leave it alone.